okay, usually people that criticize mathematics, some people that criticize mathematics, they pretend that the more mathematics is going to try to deal with infinity, the more it becomes abstract and far from the real world. My position is the other way around, to tell you the truth. And we will come back after, during our sessions, when we'll talk about maybe about Bergson and some arguments about the difference between time and living time and dead time and all these kind of things. But I think the other way around. Why? Because I think every time we try to grab a part of reality, even physically, we actually cut it into pieces, like if we were killing the motion itself into bits, like in physics, for instance. What I try to give, I know it's a little bit confused what I'm saying, but I will try to make it more clear. When a physicist wants to give a definition of motion, it's really weird, because his definition of motion is to say that it's an addition of fixed points, of points that actually don't move. So in order to understand what is motion, to describe motion, he makes an addition of little points to say, exactly, yeah. At the time t1 it's here, at the time t2 is there, at the time t3, etc. But the more, but reality is not those separated points like a countable point. The reality of motion is actually the fact that there is an infinity of points that allows reality to be what it is. So it's not, you know. And
well, you mean the continuum,
exactly,
the continuum of a smoothly varying
exactly,
something.
exactly.
Right.
So every time we try to reach something concrete, we right away deal with infinity. And so people that pretend that the real is rational, like reality is rational, they ratio etymologically, that means to cut in smaller and smaller and smaller and smaller and smaller pieces. But after having cut everything, you don't reach anything. While if you decide right away that it's understandable only with this concept of infinity, in fact it becomes more concrete. It's because it becomes more real. I mean, in a way. So I think, in a way, when mathematics, from the outside, from the perspective of someone that is not a mathematician, looks less and less rational because it tries to deal with the infinity, it's when actually mathematics is getting closer and closer to the concrete and not leaving the concrete.
So you like it more, not less, because...
Yes, I do.
It's crazy. Yeah. Well...
why is it crazy? What does it mean crazy? Because
yeah, Poincaré said it's a disease, that theory, that he hopes future generations will recover from. And Hilbert said, no one shall expel us from the paradise discovered by Cantor. But you know, infinity comes right away. If you say 0, 1, 2, 3, and it goes on forever, this is already a fantasy world of mathematics, or it's the Platonic world of ideas, if you like.
Yeah, but in a way it's a world that allows us, you, mathematicians, and people that use mathematics to do things with the world that they couldn't do if mathematics weren't there. So in fact...
It's useful, you're saying, yeah.
Donc it's not only that it's
a useful fantasy.
Yeah, but it's... Yeah, when you say it's useful, it's like if you were saying, like if it is useful randomly, you know? But for me, I think it's not randomly that it is useful. It is useful because it's related. It is useful because it has because it actually says something about reality. So if mathematics looks like a fantasy with Cantor and all that, maybe it's because the world is fantasy.
It's possible. I lost the thread. There is the Zeno paradox, by the way, or the paradox
Yeah.
of the arrow.
Exactly. That's what
which
I was
you can
referring
never
to.
get from here to here.
It's what I was referring
Because
to
you've got to
indirectly.
get to the midpoint.
Exactly.
And then you have to get to the midpoint of that.
Exactly.
And so you have an infinite number of points. So how can you do an infinite number of points? So motion is impossible, according to Zeno's paradox.
And the arrow count never touches the
right. And Achilles never catches up with the tortoise.
Exactly. That's
And it's a very good argument. They ask themselves a simple question. Let's imagine, well, as a child, you take a piece of paper, fold it in half, and then fold it in half again, and then fold it in half again. Well, in practice, you're going to have to stop at some point. But you ask yourself, can this line be divided into two halves? Can each half be divided into two halves? Can you go on forever? There are two possibilities. That eventually, that you can go on forever dividing a line in halves. The other possibility is at some point you get to atoms, to indivisible pieces.
Yeah.
You know, those are the two logical possibilities.
I think we will deal with that further on, because I had planned to talk about atomism on one side,
right?
Like what we could call like the substantialist school, meaning like the real world is what is underneath, and when we have reached the substance, that's what take the world, what's maintain the world what it is, like it's the atomist. And the other, that I would call the essentialist, they think it is the structure, it is the harmony, like the Plato or Pythagoreans, you know. And I think the one that has actually solved this difficulty is Leibniz. But I think we will come back to that.
Leibniz.
Yeah, I think Leibniz solved that. I mean, it's not.
The labyrinth of the continuum, he calls it.
Yeah. And even the idea of perception and a-perception in Leibniz. But anyway, now that we have a little bit, we entered a little bit with different windows and different doors into our subject, which is infinity, like to mathematics, to philosophy with the Zeno paradox and different ways.
And of course, there's a theological connection.
Of course, directly. I'd like to ask you, because I'm, as a mathematician, or even as a person, I'm as a mathematician, as what you are, what will be your definition of the infinite or infinity? Because you are dealing with infinity all the time, so you might have a definition, something that comes to mind when you are thinking about it. You know, not only about it's not only about Cantor and all, it's just about you yourself. How could you define infinity?
Yeah, well, one attitude is that it's a fantasy world that we mathematicians live in. And then the other attitude is that this world is a world of appearances, is not the fundamental reality, and that this is Plato's position, that the world is, or Pythagoras' position, the world is built out of mathematics, that God is a mathematician, and that the underlying substrate or basic reality, the ontological basis, is mathematics, that this is the hidden structure of the world.
Except that Plato hated infinity, because for him mathematics, that was the perfection of the ideas of everything, because for him apeiron in Greek means non-finite, something that is not, and so of course mathematics is just what is perfect, a priori perfect.
But Greek mathematics deals with infinity. For example, Euclid has a proof that there are an infinite number of prime numbers.
Yeah.
So
yes,
some infinities were good.
Yeah.
That's considered to be the classic example of a beautiful piece of Greek mathematics.
So, but for you, what is the definition of infinity?
For me, what's the definition of infinity?
Because you're dealing with infinity all the time. I mean, in your career, you talked about it, you wrote about it. So, do you have a basic ground or
do I believe in it? Do I believe in it?
Do you believe in it? Because you say a fantasy, but I'll be very happy to know what you mean.
It's like a religion.
Yeah, maybe it is.
The infinite, or the world of mathematical ideas. So the question is, what is the basic reality? Is the universe has to be built out of something, right? Are you going to build it out of marshmallow, or what are you going to build it out of? It has to be something.
I don't know, but I'm wondering.
Clear and precise. Mathematics is a good candidate, I think.
But you know what? When we're saying, I like to enter into the very structure of the question themselves. Usually, when we say, you said something very interesting, because you said, but the world has to be built, made out of something.
Right.
But
what is the ultimate reality? The
and what does mean
basis?
Built? Doesn't have to be built. Doesn't have to be built because we think it has to be built because we actually build things here and now in this world, in time. We have built machines. We build things all the time. We know that even biology is building things, but maybe the universe in itself doesn't
need a
anything.
builder.
No,
doesn't need
a builder. Doesn't build anything. And the very concept of building is something that is related to our reality, like when we say, for instance, that the Newton's law works in our reality, but we know they are wrong fundamentally at another level, but it's still useful. So when we say build, we actually ask a question we can't answer, not because we, because actually the question doesn't have any sense relatively on another.
Einstein asked, did God have any choice in building the universe, or was there only one possible design? Now, I don't know at what level one wants to interpret that as a metaphor or not, but...
Yeah, but yes, that's... Yeah, we will. I'm not going to carry on this because I think we are going to. So your definition of infinity on one side will be like the fantasy world. On the other side, that will be, in a way, whatever it is, the building block, the ultimate
G.H.
reality.
Hardy in Mathematician's Apology talks about this. He says, if you look at a chair, the more physics you know, the stranger the chair looks. The reality dissolves because it's, there are molecules, there are atoms, there are force fields. There's the Schrödinger equation, quantum mechanics, where particles start looking like waves. So the more you look at the chair and the more you know, the stranger a chair becomes. And this supposedly is everyday reality. But he says, 1, 2, 3, 4, 5, that is absolutely real. You look at them and they don't dissolve into quantum mechanical probability waves like a chair does. So he feels that 1, 2, 3, 4, 5 are more real, that there you have contact with a real reality, a reality of mathematical ideas. He considers more real than the very foggy, nebulous reality of physical objects.
Because, for me, there are two ways to define infinity. The first is to take it like in the first meaning, like the etymological meaning. Sometimes it's helpful, not all the time, but I think it could be helpful to say infinity is just that what is not actually finished.
Right.
So if it is not finished, in order to exist as something, because something has to be finalized in a way to have limits to exist, it has to be finished by something. And I think what actually finished this thing itself is the relation of the thing with other things. And so I will say that if we are all the time existing on one side as a finished things, in the relation that we are actually having with others, with the world, and all the things that makes us what we are, like we are breathing, it's a relation, we are all in rhythm, etc., etc. And so we are finishing ourselves, but in the same time, it's never finished. So that means, and it will be the second part of the definition, that because it's unfinished, it's never finished, and I can always add something to what I am. It's what is called progress, and it's what is called time, actually. Most people, they think time like a program, or they misunderstand because they confused program with progress. Program is like in a computer when you actually compress the future. You pretend that the future is already here because it's a program that you have made it, that you have made it. But in fact, it's not time. It's the try to suppress time. So it's the try to suppress the relation that is time in itself, in its infinity. When I mean in its infinity, because time is just the fact that it's just the expression that things are not finished yet. So in order to finish themselves all the time, they need time. So they need progress. So they need change. So etc. 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 So I think there are two ways there. On one side, there is the fact that infinity is just the fact that things are not finished, and it's a mystery. It's a real mystery. Because they are completing themselves all the time. They are completing themselves from the outside. So they are mixing their identity. In the same time, they can still be identified as what they are. And on the other side, that means that a thing is always more than what it seems it be. And we reach what you actually said. It's always more. So it can't never be reduced to what we think it is, because when we look at it at a certain moment, and this certain moment is not the thing, because the thing is always more than what it is at this moment.
Yeah, with Cantor's theory, when you try to grasp it, it escapes. It slips between your fingers.
Exactly.
But might it be helpful to mention some really big numbers? You know the...
Go ahead.
There's a number, there was a book for children that talked about a googol. That's 10 to the 100th power. So that's a 1 followed by 100 zeros. So that's a very big number.
Wow.
Okay? That's a very... there isn't that many euros in Europe. And then you can take 10 and have it raised to that power, which is 10 raised to the 100. So 10 raised to the 100 is a 100-digit number. How about a 1 followed by that number of zeros? This is a number so big you can't write it.
Yes.
But it's only a finite number. Okay? So we can...
But it's only a finite number.
We can name numbers that are too big to even write. Write out completely.
Yeah. We know that the universe will not be enough to be able to write it, even if the universe was a blackboard, you mean?
Yeah, so you can write down 10 raised to the 10 raised to the 100, but if you try to actually do the exponentiation and write the number all with decimal digits, there isn't enough room in the universe to write down that number because it has...
It's actually that I find crazy.
Right.
Maybe more because I found, and it's actually that I find crazy, because it's like if the universe couldn't contain the product of our own imagination.
Precisely.
It's just something completely mad.
Precisely, and it's very easy to write numbers that are much bigger than this. And then there's also a version which maybe goes back, I don't know, maybe it's apocryphal. The story is that someone did something for a sultan, and the sultan says, "Oh, thank you so much, this is wonderful, I want to reward you, tell me what reward do you want?" And the story is that the too clever person said, "Oh, I just have a modest request, Sultan. Here's a chessboard. Put 1 grain of wheat on the first
and the
square,
double.
then 2 grains of wheat on the second, and I modestly will be satisfied very happy
Yeah.
if you, O Sultan, can give this to me as my modest reward. And of course, it turns out it's not at all a modest reward.
Yeah, it's impossible even to.
Yeah, I think it would be bigger than the size of the Earth.
Yeah.
Maybe not. It would be 2 to the 64. That would be. It's a very big number.
But at least it will be bigger than the room that is left on the last
Well,
the last square.
Yeah, it's
But-
a very big number.